away from the important book.
That would be dangerous.
You want to make sure you stay away from the important book. We don't want to talk about that at all today while we're hacking business technology. Welcome! We've got Mr. Mark Kawasaki, Mr. Matt Hooper, and I, myself, Matt Barron.
Hoodless.
And that's it. Yeah, I'll take off my hood. Actually, my hair is getting really long. This will all get shaved. Yeah, going look. That's fine. Actually, we set another topic again this week, which is actually surprising. I'm surprised. I haven't had that much focus in 2 weeks ever, actually. And I really, I love this topic because I understand a little bit about it, and I've gone through some exercises, but I'd love to get some other people's perspective on something like this. It's service mapping.
Yeah, service mapping is a very interesting big space. Can we hear you, Mr. Kawasaki?
No, we can't hear Mark. You're gonna have to rejoin. We didn't test his audio first. Yeah, I already checked control panel. It's not gonna do anything. Well, speaking of service mapping, what we would do is we would look at this service component map right now for a podcast and say, what CIs are we dependent on? Oh, Mr. Mark Kawasaki's PC and his microphone. Those are business critical services for hacking business technology, right?
Yes. Yeah. Video based podcast, camera, microphone, internet connection, pretty crucial.
Yeah, and the idea is that you have this map so that you can quickly look at all the CIs, including Mark's microphone, and test them every time you change something or you release a new episode, for example.
But what helps you to appreciate is that not all configuration items are created equal.
Say that again? You froze.
Not all configuration items are created equal.
Mm-hmm. It's true, and you quickly can see frailty. You know, that's sort of the point. If you've got 3 or 4 CIs in a service that are always causing problems, how can you mitigate risk?
Right. Right.
And that includes components of change management. So, you know, anytime that you're pushing code to a low-level server, you know, how are you doing testing? And maybe you're doing load balancing, so you're trying some of the traffic on a specific server and only giving you 10% of the traffic or whatever. And then, you know, making sure that you're only really testing that at that moment. Because if you're doing a test against something specifically for like throughput or bandwidth or processing power or whatever have you, you don't want to be testing multiple things because you're not able to determine which one is actually causing the problems if you've got a degradation of service.
Yeah, but here's the thing, right? With system mapping and service mapping, they really are 2 different things.
Mm-hmm.
System mapping is system-to-system relationships, whereas service mapping is how, almost in essence, a function flows across it, right?
Mm-hmm.
And so it's one of the reasons why I don't talk a lot about IT services. In fact, I think documenting IT services, and for the most part, is a complete waste of time.
Engineering mapping.
Yeah, you want a system map, because here's the thing, right? Like, tell me a system that's going to run without DNS. Now, if I asked you, is DNS critical to a vital business function? You'd probably tell me, yeah, sort of. But most systems don't use static IP addresses. And most systems don't talk to each other, such as your quoting system that talks to your rating system if you're an insurance company. And the web servers that are taking in the quote probably not talking to your J2E environment via hostname over NetBIOS. Probably using TCP/IP, probably using IPv6, and probably not mapping the static map to the IPv6 address. You're probably using DNS.
Yeah.
So if DNS goes down, so does your quoting system. Hello.
Yeah.
But we don't think, and that's the difference, is I don't care from a services perspective necessarily. I care from a system response model. And that's the problem with ITSM, is because we get so hung up on the service. Everything's a service. Well, everything's not a service, okay? There are assets. Like my chair is not a service. But if I'm not able to sit in it and my back hurts after 5 minutes of standing and I walk away from my PC, then I'm not able to do what I needed to do at my PC. It's like physically there are systems and assets that are not services, but they're a component of the service makeup.
Huh. So when you say that, so how do you? I'm trying to rationalize that a bit. So
yeah, let me break it down. There are pieces of the system. For instance, let's pick an enterprise application for a second. Let's say it's a J2E environment.
Mm-hmm.
You're going to have on the front end some Apache web servers. And those Apache web servers are going to sit on a physical or virtual operating system. Let's say it's Linux, okay, for argument's sake.
Mm-hmm.
So you have Apache sitting on Linux. That talks to then a J2E stack, right? So the JSPs are out in the Apache environment. They talk to your enterprise Java beans, your EJB stack, where basically your business logic exists. You need your core Java virtual machines to be running. You need, let's say your EJB stack was also Linux. You need your Linux operating system to be running. You need your core Java virtual machines to be running. And then that communicates to your database through what's called a JNDI, Java Network Database Interface Layer. It makes queries to the database. So the database needs to be up. Those are component makeups, right? And we can look and we can run tests. I can actually instrument or wrap the JVM with tools like Dynatrace that will look at every JSP and did it instantiate, and did it actually call in through my JSP into my, from my servlets to my JSPs to my EJBs up through my JNDI, and it can tell me the response time for every method and request. But the question is what does it matter? See, the problem is systems fail all the time. And if you focus only on system and component failure, you're looking for a needle in a pile of needles. By mapping it to services at critical component levels, understanding what those services are and using tagging systems throughout all of your application codes, throughout your application definitions, by tagging them against your CIs, you're threading that needle through the pile of needles. So when you have a business failure like, hey, I tried to attach a quote and it wouldn't attach, you can follow that thread and say, oh, attach a quote is a vital business function of quoting, and that requires this repository of Amazon S3 file share, which isn't even in our control. That's out in the cloud someplace. So let's look and see if that's available. Let's look and see if that's up, right? But if you don't map the vital business functions down to the component level, you lose that. But everybody in IT service management wants to say, hey, let's put a bucket around J2EE services. It doesn't matter. That's stupid. Putting a wrapper around IT services is absolutely useless. Just map vital business functions to your, what URL do they interface to, and then map it down from there.
Hello, can you hear me?
Yes.
Yes?
Yes.
Okay. Yay, so fun topic. I'm back. All right, so I have something to say about that, Matt. I think that's all well and good. I've done a lot of this, and the one thing I found is that nobody knows the map. Nobody. No matter what. And every team or group or functional unit within IT knows one relationship. Pretty much. So the database team knows what servers their databases run on, for example. The server team knows what network switches the physical servers are connected to, or what physical servers the virtual machines are running on. And so what I found is that mapping a service end-to-end from the business perspective is not an IT skill. It's a skill of coordination, finding out all of those one-step relationships and somehow piecing them together.
It's a skill.
It is a skill, yes, but it's not necessarily a technological skill.
Here's the bigger problem, Mark, and I've also done a lot of this work. My feeling is always, especially in the performance engineering space, because when I ran Vigilant and we were doing performance engineering, we had to map the infrastructure to find the point of constraint of why an application wasn't performing like it needed to. And what we realized is that someone did have the map. It was over an enterprise architecture. Then the map changed when it went into development because they couldn't actually meet enterprise architecture's management specifications and had to compromise with some widgets or some custom plugins.
Yeah.
And then when they went through testing, they found additional things that weren't mapped there, and so then they made some more additional modifications, and then finally it went to operations where they said, well, hey,
yep,
we deploy things a little bit different here, and then they made additional modifications.
Oh my God, it's a nightmare!
It's funny that you say it that way, Matt, because that's exactly the path that I follow. I always start with the architecture review and the diagram there, and then I take it to the next team and see, okay, what does this mean to you? This is logical. Let's get a little bit physical here and see what happened. What are the actual servers? You know, because architecture doesn't necessarily care about how many servers are in a cluster, for example. They just care that a cluster is there and it's this type. And, you know, so you've got to go on, and then you get to, you know, the network layer and architecture. That's so far removed from what architecture cared about to begin with, right?
That's right. But this, my friends, is why DevOps is going to put configuration managers out of business.
Because you can automate it.
Because when you are architecting it, you are building a schematic in a tool like Ironworker or you know, some kind of Puppet, Chef, and you're setting up your configuration that you want deployed, and you're hitting a button, and because it's software-defined infrastructure, the servers, the applications, the web service, the database, the network, it's all software-defined. It then builds it and then releases it. So what's in production? What you designed. Right?
Yeah, it makes it a lot easier to point accountability and responsibility. You basically say, like, you are responsible for this small portion of this design. Manage it. Or you know, before you even go live, you're designing it so that you've got option behind your work, so you're really just managing the automation.
But what I've also found is that that works well until it fails, and then a lot of times it's designed well to kind of take care of itself, but when there's a failure within the systems that are automated, a lot of times it isn't designed well enough to recover. So, I mean, with the disaster situations, I mean, you may have a main data center and a backup data center. You can't guarantee that one is primary and one is secondary because people do things in a human way, and your secondary data center may be primary for some individual components, and you know, so that stuff sometimes comes into play when there's a failure, and still your configuration isn't mapped well.
It's all true until AWS is ubiquitous.
Yeah.
We used to have a police detective who was on our team, left police and joined IT. He was an incredible requirements gatherer because he could read people's faces and body language. But he was also an excellent performance engineer because he would use this expression, follow the money. And what he was in essence saying was follow the business transaction, right? And here's the challenge that we have is when people want to create this monolithic CMDB without defining what the appropriate configuration item types are, everything becomes a CI. Mm-hmm. Well, if everything's a CI and everything's a service, then every CI is a service. Every service is a CI. And that doesn't make any sense. That's nasty, right? And so, but if you back it up for a second, you say, well, wait a second. We're gonna allow some systems management to exist in our environment because we're IT people and we manage assets and we do things. That's what we do. If you read Rob England's IT skeptics type work.
Pets. We have pets.
Yes. And so, in essence, what you have is you have layers, right? Like an onion or a parfait. You have layers that allow you to extract the information you need to see when you need to see it. And here's the value of that. Like you're talking about, Mark, what's my disaster recovery and IT service continuity management strategy? Mm-hmm. Well, I was able to look at my true business services and look at my locations and my functional groups and then the systems that they use to support that business service and the interfaces, and then I got to the asset level. I can very quickly isolate points of failure. If I'm looking at capacity or availability, I can quickly isolate points of failure or points of constraint. It's the layers that, because we don't build, like, when's the last time you saw a configuration management interface that was designed for a network engineer?
That was designed for what? Say that again.
Network engineer.
Yeah.
That talked about management consoles and IP segments and vSpans and routers and hubs and switches and wireless. Never. Every stinking configuration management interface looks exactly the same. What is your CI name? What are its attributes? It's like blah, blah, blah. It doesn't make any sense to that individual at that layer. Whereas if you did it, they would populate it with useful information, or they tie it to their management.
Well, I think one of the problems is the mapping is done from an IT perspective, like you're saying, Hooper, and the problem with IT is that they don't have a way to prioritize business functions. They just look at technology across the board. So, for example, what I do when I start a mapping is I get with the business and I have them prioritize their business functions within a system. So if there are 10 things that you do within this service or system, prioritize them from 1 to 10, and let's just deal with the top 5 after you've done that. But that's different than the way IT would take it, because IT sees 5 database connections and they're all database connections, so I've got to map to every one of them. But maybe one of them is the 10th thing on the list for the business. In other words, there's some screen, 18 screens in, where they click submit on something that's not even that important, and that makes a specific database call that really almost never happens, and they don't care if it goes down. And so why are we mapping that at the same level as the most critical business functions, right?
Yes. Yes. All CIs are not the same weight.
Right.
Yeah, and that's why having the map helps.
Yeah.
Right? I mean, then or even just having the right teams aligned to said service. Because then you can say, like, look, numbers just show that throughput's stopping at you, or, you've got this much data failure going through your system, through your CIs or your code or whatever you want to call it. And you can hold them accountable, or at least track it. I think that's sort of like the value that I see in having something like that. It's a map that everything can kind of align to.
Yeah.
It's a starting point for whiteboard discussions.
And also, monitoring. I don't know how anyone doesn't map business functions if they're monitoring with synthetic transactions for SLAs. I mean, I don't know how you do it without it.
Right.
Because I mean, if you're not mapping it, then you're not giving true business SLAs based on performance at all. You're just not. So, I mean, because either you're not, or you're not able to correlate anything. Maybe you're doing some synthetic transactions that perform business functions on a regular basis, and you can tell how often that's available. But if you're not mapping the service end to end, then you can't correlate component failures to those availability outages at the business function.
Yeah, without spending a lot of money on people.
Yeah.
And you have to map it, and even your mappings, those have to be, from a monitoring perspective, again, have to be in succinct categories. We used to, way back in the olden days, use FCAP, which was fault capacity, availability, and performance. We've since morphed that to what I call FCHAPS, which is fault capacity, change, availability, performance, and security. So, because a security event versus an availability event, you need to succinctly quantify that. And again, it has to be a federated model, because how you monitor a hypervisor for a VMware or vMotion type capacity availability issues. It's completely different than you monitor OEM from Oracle for database and instance or extent performance capacity issue.
See, I mean, I'm not that advanced when I get out there and do this work. I'm letting each team determine what their critical events are for their components.
Mm-hmm.
So you tell me what your critical events are. I don't care if they're F or C or H or S. Just you determine what they are, and then we need to make sure it's mapped to the synthetics across the top. So if the synthetic does not turn red, but your component turns red, we know there's a failure at your level that's not affecting the users.
So how do you know it's a failure, though? Let's say it's a capacity. See, this is why I
Well,
believe that
I don't mean it's down. I just mean there's some critical event that needs action.
right. And see, that's why I build those categories, because a fault's going to be an incident. A capacity is, a performance is going to be some kind of problem management, investigation, proactive.
Yeah.
Availability is going to be an incident. Security is going to be an incident that's going to be specially handled.
Right. And even a failure. I mean, you may have a 2-node cluster and one of the nodes goes down. It may still not affect the users at all. So
Yeah.
I mean, but it's still an incident that they want to resolve, at the component level.
Yeah, I wrote a blog.
Even if they're not measuring the quality of their service.
In fact, I think it's vitally important for every IT organization to take their vital business functions across the organization, monitor them synthetically, and when they have component failure, and the synthetic monitor shows that there was not a business impact, and that the service desk tickets show that there was no call in for it, that IT promotes that as a win.
Mm-hmm. Right.
Stuff breaks. That's life. I used to call that my service outage avoidance metric.
Yeah.
And I actually rewrote my bonus based on that, because I didn't want to be penalized for component failure when I systemically addressed my single points of failure for mission critical vital business functions and services.
Yeah. I mean, I think ITIL still talks about component availability as if that's meaningful in some way, and it's just not.
Well, it's an opportunity. It's an opportunity to spend how much money you want on that. Like, it is waste. So do you want to spend $1,000 fixing it today, or do you want to spend $100 fixing it in 2 weeks?
Yeah, I mean, component availability and capacity need to be measured from an engineering standpoint. Like, I need to watch how much disk space I have, or how much memory or CPU I'm utilizing. But if it's not in correlation to the business outcome, then it
has very different meaning.
Yeah, it's a very different meaning.
One of the things that I found interesting in getting into all this is just the difference between real user monitoring and synthetics. Real user monitoring is great because it tells you how things are going for the actual users that are in the system right now. But one of the interesting things is you cannot measure for the purpose of SLAs based on real user monitoring. You almost have to have synthetics, because real user monitoring will just show that there's no activity when the system's totally down.
Oh,
that's right. That's right.
Whereas synthetics, it's expecting it to do a certain thing. It's not just reflecting what's actually happening. So that's an interesting thing.
Huh.
We used to talk about that in the banks all the time. It's like you could watch your teller transactions, but if you didn't have a synthetic running at 7 o'clock when you knew all your tellers were coming in at 7:30, you weren't buying yourself a window.
Yeah.
The availability issues.
You would just be like, oh, not much is going on right now. Well, yeah, duh.
Huh.
But the problem with that too, though, synthetic though has an overhead to it.
Oh yeah.
It's
Yeah. How do you invest in that? What is the automation?
Well, we used to. So most of the work that I had done was either with CompuWare or Mercury Interactive, which were the two leading. At the time, they were the two leading automated regression testing tools. Mm-hmm. So we would leverage the scripts, and then we would build in variable data, and we'd build in test data into our production that we could use consistently. But that didn't always work. And now there's Selenium, and there's a bunch of other tools that you can use, and you can script it. In the DevOps space, what they try to do is they try to do component level testing. Mm-hmm. And because of microservices, it does make synthetic a little bit easier. So not only are you software defining your configuration, you're also software defining the test and validation. And then you roll that into production. And at a microservices level, it's a little bit easier, right? Because it's just can you create, read, update, or delete a particular transaction in that microservice?
Yeah, I use both right now. I mean, it's important to know within each component what's happening, even at a synthetic level. But it's also important to run it across the top from a user stepping through transactions. But you don't necessarily need to hit it as hard if you've got synthetics going on for each component as well.
Right. Right.
Yeah, and it's nice to be able to just point at production data all the time. But man, you know, it's just about designing well. What a craft.
Yeah.
I guess that's what we should be teaching kids.
Well,
how to design good systems.
Yeah. I mean, the production aspect is a limitation. I mean, you can't necessarily create records unless you clean up those records.
You're muted, Hoop.
Yeah, I think I think the training needs to be something that is brought in around the business side of it, though.
Mm-hmm.
Yeah.
How transactions work. Like, most IT people don't understand the concept of order to cash. You know, had I not understand that, I could never have done performance engineering. I could never have done service modeling effectively, right?
Well, let's switch a little bit and talk about the cloud. I mean, one of the questions I get most often is, oh, well, what do we do when it's a cloud service? We don't need to map it, or how do we map what they have over there? I mean, all these different takes on it. I mean, my response usually is, if we're paying for a cloud provider, we don't need to know what their architecture is, because that's why we're paying them, number one. Mm-hmm. And number two, there's no reason why you can't still map with the cloud service. I mean, you have your authentication pieces that are probably on site, you have your internet presence, you have all these different things, and you want to make sure you understand how that interacts with the cloud provider and potentially even run synthetics against a cloud provider as well. It doesn't change the fact that you still need to map it. What do you guys think?
Yeah, Cisco has a service called Cloud Consumption that will actually turn on and enable monitoring that looks at fault and performance capacity of cloud usage and cloud services. And I think they have like 600 applications they've developed, Evernote, Dropbox, the Google Apps, Office 365, all those kind of things, a whole bunch of different cloud, and it will give you reporting and analysis of which users across your environment use them, when they use them, how much impact on your infrastructure did they use. Because cloud doesn't mean that you gave away everything, right? Especially if you still have at-office workers.
Well, what I love about that, what you're describing there, is it's kind of it's shifting the focus to how we interact with that service instead of how it's architected within that service, and I love that.
Right. I could care less what VM hypervisor they're using, what kind of, are they using Kensington memory? I don't care. But if the business function's not available, if I haven't validated it synthetically, like you said, or if I don't know which part of my system's interface, because not if you have cloud, you always have integration.
Yeah.
So.
Yeah, I think
mappings.
Just being able to talk to people about that stuff too is really valuable. You think of something like, what if you're getting gouged by a vendor and you don't even realize it because you've never talked to the other people that are there? I think that's another reason that I think a map is useful. You can quickly see, like, who is the team? Who do we need to talk to constantly? And if you don't have, like, physical representation, then it's even more important when you're, like, working in remote locations and offsite all the time.
Yeah.
And this is the problem with shadow IT, right? Is they'll go out and they'll get a cloud service to all of a sudden expand their capabilities, but did anybody think about backup? Continuity, with agreements, privacy.
Yeah, what was there was a URL shortener that just closed down, and like any business that was using it now, you can't. All those links are dead.
That's hilarious.
I don't remember which one. It's not Bitly. Oh, it's TwitPic.
Interesting.
Oh, wow.
And they specifically stated that none of it will be retained. All of it will be deleted. Like, you can't, the commons, what is it? There's some commons effort to preserve everything on the internet, archive.org. And they won't even give it to them.
Wow.
Like, it's already public information. It's an interesting debate. Read about it.
Sounds like something Google could make some money off of.
Speaking of automation, have you guys seen the Tesla autopilot?
I haven't seen it, but I read about it.
So on freeways, you turn on autopilot, hands off the wheel, feet off the pedals, and it does everything for you. You want to change lanes? Turn on the signal. If there's a car there, it won't go.
Mm-hmm.
Unbelievable.
I still believe one day cars will be, it will be illegal to drive your own car.
Oh, I hope so.
Me too. I really do. But that's not very Merca, so I don't know.
Oh, come on now. In other news, there's some pretty interesting stuff happening in the security space. I don't know how much of you pay attention to ransomware, but the FBI actually admitted this week that sometimes you have to pay the ransom for ransomware. They've actually got several cases where they've shown examples of this. The ransomware encrypts better than you can break, and so you can't even, like, even if you find your data, there's no way you can get into it. And it's all automated. The whole scheme is automated. So even like payment, so it's usually around $250 to $500. Really interesting. I'll share it in the show notes.
Is that the same thing as? I mean, I saw an article about spam ransom for Ashley Madison accounts. Like, they were just spamming the entire list and making kind of these vague threats that they would be exposed if they didn't pay. And they sent it to, like, the whole list, and they're just hoping that, you know, a few people pay them $500 or $1,000.
Did you see that Anonymous is threatening to release the names of 1,000 KKK members?
Ooh, wow.
Which is really interesting, given that Anonymous, right? Anonymous. But I think someone put it well, and they said, what if they mislabel someone? Like, what if they got it wrong? And I think people will take it without a doubt that it is truth, similar to Ashley Madison, although, however, we know that in that case, there were several people that signed up for the service, journalists, you know.
Yeah.
They weren't there for nefarious purposes.
Mm-hmm.
Yeah, but people who put on hoods and do, you know, terrible acts, they have to be trustworthy. And they have to be trustworthy.
True, Mr. Hooper.
Oh, boy.
Speaking of trustworthy, there's an interesting article about a security service that was studying phone habits, and they purposely lost 20 iPhones, Androids and iPhones, hoping that people would steal them. And then it's got, I guess it's got an OS layer protection tool on it, so that even if you erase everything, you're still not blowing away the security application. And they're able to, like, take pictures and track you and all this stuff without you even knowing it. And so they know who has the phones that were stolen. Really interesting article.
Isn't that baiting?
Yes, absolutely.
Yes.
Speaking of which, what do you do if you have a broken smartphone that you can't get into?
What do you mean, specifically?
Oh, like it's just the screen won't come on, for example.
Oh, you take it to, if it's an iPhone, you take it to an eye repair shop. There's usually one in malls now.
Well, I mean, if you just want to get rid of it, what is the safe way to get rid of it? Because obviously, plenty of other people could get your data out of it. What would the normal person do?
Sledgehammer.
Sledgehammer.
That's
Okay.
interesting. You would want to get memory somehow. You would want to destroy the memory specifically. You could look up the schematic and actually take the chip and then either apply electricity or an extreme amount of heat to it, or like that.
Okay, Baron, we started off saying what would the normal person do, and I don't think electrocuting memory chips counts.
Well, I mean, if you don't want someone taking it.
That's awesome.
Right? You could actually recover it.
So take it to someone that knows how to electrocute memory chips, and then you're good.
Just throw it in the microwave for a couple minutes.
Throw it in the microwave. That's a good one.
It probably would actually fry it enough. It would have to be quite a while, though, because it would have to get up to soldering temperature, which is 700 degrees.
Okay, so you heard it first here on Hacking Business Technology. Microwave your old cell phones.
Actually, don't do that, and don't try this at home. But if you do, just make sure that you let people know that you're going to be hacking business technology. All right, we'll see you next week. Have a good one.
Bye, everybody. Thank you.